Okay, so this is part 2 of Conic sections, talking about the ellipse, the second problem right here. And we, in part 1 of the video, just found the center right there at -1, 3. Let's take a look at what else we're given here. It also tells us that the major axis has a total length of 10. And remember, your foci are always along the major axis. So right here, we've got an imaginary dotted line, and these are along that major axis. That's a total length of 10. So right now the foci are 1, 2, 3, 4, 5, 6 apart. So we want to expand that to get to the vertices, and that should be a total of 10. So from the center, 5 and 5 would be a total of 10. So let's go out from the center 5. 1, 2, 3, 4, 5. We just need to go 2 more out from the foci. And 1, 2, 3, 2 more out here, 4, 5. This would be our other vertice right there. So this would give us our complete major axis right here from 1, 2, 3, 4, 5, 6, -6 all the way to +4 would be a total length of 10. Great, so we've taken all the information from what they gave us and drew it in a picture. So let's think about the form of an equation for an ellipse, and let's see what information we have so far and what we have left to find out, so that we can complete our equation. So if I think about my equation, on the top, all I need is my center, which I have. So let's go ahead and write that. This would be x plus 1 because of the -1 for the x value, and y minus 3 because of the +3 for the y value of my center. Okay, got my numerator sorted out. Now for the denominators, I know that what goes right here is going to be my distance to the side, from the center to the side, squared, and underneath y is going to be my distance that I go up and down squared. So I don't have how much up and down, but I do have how much side to side. This is a total distance of, we said, 1, 2, 3, 4, 5, yep, 5. So 5 squared would be 25. So we've got the bottom of this one. It looks like what we're missing here is our b squared, or our distance up and down. So I don't have b squared, but I do have a squared. I have 25. And I also know the distance to the foci, which was the distance that we call c. So I know my foci is a distance of 3. So at any point, as long as you're giving 2 of these 3 distances, you should be able to find the other one using the equation c squared equals a squared minus b squared. In the last example, we knew a and b, and we were solving for c, the distance to the foci. In this one, we have the distance to the foci, so we have c, we have a, we want to find b. So we're going to say c squared, which would be 3 squared, or 9, equals a squared, or 5 squared is 25, minus b squared. And let's go ahead and solve. I'm going to add b squared over here to make it positive. 9 plus b squared equals 25. Subtract 9 from both sides. B squared equals 16. And take the square root, so b is plus or minus 4. So that means if I go up and down 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4, we would have our ellipse looking something like that. A rough sketch, a little messy, but stick with me. Okay, so we went 4, getting a little cramped here, 4 up and down, so that's our b value. So 4 squared would go on the bottom here, would be 16. So my final equation for this ellipse would be x plus 1 squared over 25 plus y minus 3 squared over 16 equals 1.